Question is asking for systematic and unsystematic risk, and then the amount of risk diversified. So there are three things we need to compute. Let's start with the unsystematic one. So the general formula, not mu, RA minus RF is equal to beta A RM, the market excess return, plus something epsilon, say epsilon A. So that's basically the residual in the regression. So then we take the variance of this whole thing. The variance of RF is always constant, so ignore that. This is when you are multiplying by something, the variance multiplied by this thing squared, and this is sigma m squared plus sigma epsilon A squared. So that's basically the main equation. You have anything random, you just decompose it into this market part and the not market part. So this is systematic, this is unsystematic, and what do we know? We know sigma b, so we start with stock b, and then this equation implies we have beta b. We know beta b is 3.2 squared times 0.1 squared from part A, plus that thing we don't know, so we can solve for this. And for C, we can do the same thing. This is 0.4 squared plus 1.2 squared. Okay, so from these two equations we can solve for these two. I'm not going to solve to get the new, no, it's not plus, they're equal. Okay, then for the portfolio it's exactly the same equation except for we're replacing A by P, so it's the same idea. So the first thing is we need the portfolio beta. So sigma beta squared, sigma p squared is the beta p squared times the 0.1 squared plus that part. That part is the sum of these two things, and it's equally weighted, so it's half-half. So that's sigma p squared, which is equal to the first term. The beta is equally weighted as well, so it's half of first beta plus half of the second beta. And the whole thing squared, remember, it's the whole thing squared, not the individual square, and then average it, because it's beta p squared, not, or whatever the other one is. Plus this thing is half of the first one. Okay, first sigma a squared and another half of the second one. There are no covariance, so we don't have that covariance term, where these two are coming from these two equations. So now we have computed sigma p. What's the other thing? So that's the risk of the portfolio. So with diversification and without diversification. So this is with diversification. And the other thing we need to calculate is without diversification. Which means just, I think technically it's not right, but I'll just write it. This is basically like assuming they're independent. So diversification does not help because they are independent. So when they are independent, the risk is half of the first one plus half of the second one. So with diversification is this thing we calculated. Without diversification is this. So take the difference of these two, we will get the amount of risk of diversified. So you can compute. Let's write it. So this is called, let's not call this. Call this x, call this y, then x without y minus x is the amount of risk diversified.